In this section, we will learn about two important data structures in Python, the dictionary and the set. And the dictionary has a lot of details, so let's start with it. Let's try to make some comparison between list and dictionary so that it helps us to understand the shift from that to that one. When we define a list here, assign it to a list of 10, 22, 55, then we know that the index of 0 is 10, index of 1 is 22, index of 2 is 55. So we can print here the list of 1 is 22. But indexing the array must be limited to only these three values, 0 and 1 and 2. Now moving to the dictionary, which we create in the following way. You open two curly braces and start to write 0:10. So this is say for now, index 0 going to the value 10. 1:22. It means index 1 goes to the value 22. 2:55. It means 2 equal 55. Leave that for now. Now try to use a dictionary. Dictionary of 1 will be 22 because the value of 1 goes to the 22. Now the interesting thing here about the dictionary, it is more flexible in what we use to index. So let's see here we can write something like 1, 2, 3, 4, 5, 37. So we can print the dictionary of 1, 2, 3, 4, 5 to get the value 37. In fact, we don't call it index, we call it a key, because the dictionary is much more flexible in its keys than the list. The list is just integer and the value is limited to 0 to the number of elements minus 1. But the dictionary, you provide the keys or indices if this is easier for you to get. We provide the indices so that we can do the mapping that we want. And this indices can be negative and can be string. It's very flexible. So we call them keys. Like here we have a key like 0, 1, 2, 1, 2, 3, 4, 5. And the format, as I said, you open two parentheses and then you start to write key 1 value 1, comma, key 2 value 2, and so on. What happens is the dictionary data structure will associate the key you provide to the value. So the list by definition is associating index 0 with 10, index 1 with 22, index 2 with 55. Memory wise, the list to do that behind the scene and in a simple way, consecutive memory, in a nice way to point to this type of pointers, but things here to allow more flexibility is a bit more advanced in the memory. Let's go more. Here is an example where the dictionary is having keys of character A, character O, character G, which are strings, and the value is strings. Now as you see now, the dictionary become much more flexible. I can here come and say print a dictionary of string A. You get the word alpha. In memory, you can think of it like the following. We have something called the keys and come something called the values. And we have here the bunch of keys that we used, which are the A and the O and G. And we have here the corresponding value. As you see now, we are indexing the dictionary not just with an integer from 0 to n-1. We are indexing it with what? With even a string. If you try to print the dictionary, it will be printed in a similar way to the input structure. You can also call the function .keys, which return an object of type dictionary keys. It will have the A and O and G. Or dictionary.values, which will return for you the dictionary values object of alpha, omega, and gamma, which you can iterate on all of them. There is one thing here to keep in mind. One of the restrictions about the keys, they have to be immutable objects. So something like the int, float, tuple, string. And remember that float is an approximate, so it isn't a good idea to try to index a dictionary with a float value. So let's create here a dictionary. We have here a class employee, which by definition will not be immutable. I can create something like minus this big number, Mustafa. So this is the key and this is the value. I can create a string. This is key value. I can create a tuple. That's okay. I can create here a key and put even a class object and a number, and I can put another dictionary. So it's a dictionary of dictionary. But observe that you cannot make a dictionary of 1 and 2, which is list. Why? The list is mutable. You cannot even create a tuple of list. The tuple is immutable, but its content is mutable, so it will not work. The error will be weird about for you for now. It will say that type error unhashable type. The word hashing and the hash function is something that you should learn during a data structure course. Specifically, or let's say informally, the key here will be converted to some integer in a bit wide width according to the given input. So every input will be hashed and converted to something else. You don't need to take care about that at the moment. Update and delete. We can make normal updates. I'm here creating an empty dictionary, and I started to put the dictionary of 12 equal something. We don't have any kind of restrictions on the values. The values can be the same, they can repeat, they can be whatever. So I can say dictionary of 12 equal this value, dictionary of Mustafa equal this value. Now you can print it to get the output as we entered it. I can update the value with dictionary of 12 equal hello. So we change this value to this value. You can also print the keys to see that we have this new key. You can delete a key. If you try to delete a key like deleting 12, you will notice now that we have only the Mustafa. If you try to print the dictionary again, you will get a key error equal 12. Like a key error 12 means the dictionary doesn't have a key with the value 12. You can reset the value again, dictionary of 12 equal 10, dictionary of 12 plus equal 5. So try to think of dictionary as a very flexible list. You can also bob a value, so you can bob 12 with a value. Now, what if you would like to do something? You would like to bob a value, but if the value doesn't exist, you bob with some default value. For example, here I'm saying bob hey. Observe that hey doesn't exist. So you're saying if hey doesn't exist, return 37. Otherwise, you will get an error that this key doesn't exist. So this is a point of providing a default value if the key doesn't exist. Note that if you try to print the dictionary, the word Dict, you will get that there is a class Dict. So Dict is actually a class name. In most of the code, I was lazy, and I think most of them I used the Dict as a variable name. This means that we cannot use the dictionary anymore. Please don't do that. Just use the word like a DCT instead of DICT. So here, what I'm doing here, we lost the access to the class. We rarely need it, but this isn't a good coding way. This is as same as don't use a variable like len because there is a len function. Don't use a variable like sum because there is some function. Don't use variable Dict because there is a class named Dict. That's all.